Hello class, today we are making scale drawings using the parallel method. So your essential question is, how do I scale drawings using the parallel method? Learning intention. I am learning to make scale drawings using the parallel method. Okay, the parallel method is where you will use straight edges. You might use a square and compasses to find vertices that are parallel to the original vertices. Now remember what the scale factor is. The scale factor is that ratio between the scale of a given object and a new object. In other words, you take your original length, multiply by your scale factor, and you get your scaled length. So let's get started. Using this figure below with center 0 and the scale factor of 2, and the following steps create a scale drawing using the parallel method. Step number 1, draw a ray beginning at 0 through each vertex of your figure. So I'm going to take a straight edge and I'm going to go through each of my vertices. Okay, so now I've taken my straight edge, I've gone through each of these vertices. I'm going to use my compass next. I will be adjusting it for each vertex. If I want it to be twice as big, it has to be twice as far from my vertex. Okay, so there's my first measurement. I'm going to go to my vertex. That should be twice as far from my original. Remember, we are able to get off because we're not perfect people. So let's look at A. A looks like it is going to be close to the same size as C, just a little bit longer. So I'm going to do A next. There's my vertex. There's my new vertex. And finally, I'm going to use C, or B. B is the longest the farthest away from our origin, or our center of dilation as it is called. So here's B. Gonna come out here. Ooh, I got off a little bit, so I'm going to erase. Guess what? I also did not make my ray long enough. Okay, so I'm going to make that ray longer. Now, I've got those points of intersection. These are the new vertices of my scaled figure. Now we connect our dots. This will be C prime, A prime, and B prime. And that should be twice as big. If you notice, it's a little bit off. These two lines should be parallel. All your corresponding lines should be parallel to your original figure. Because we make human errors, sometimes it's not always the case. But it looks fairly decent to me. Okay, so how is it actually used? How many of you have t-shirts at home that have something on the front? Okay, if you have a t-shirt with something on the front, if it is a picture, it might have had to be scaled down. So if a company wants to print the face of the Statue of Liberty on a t-shirt, the length of the face from the top of the forehead to the chin is 17 feet and the width of the face is 10 feet. Given that a medium-sized t-shirt has a length of 29 inches and a width of 22 inches, what dimensions does that face have to be to produce a scaled version that will fit on the t-shirt? So, in your mind, picture what a person's face looks like. What shape would you use? Would you use a square, rectangle? What kind of a shape would you use? For me, I think that the closest shape would be a triangle. Your answer might be different. Maybe you said oval. I don't know. But for me, triangle would be the closest because you're going to do a rough sketch. Okay, knowing that the maximum width of the t-shirt is 22 inches, what scale factor is needed to make the width of the face fit on the t-shirt? Explain. Okay, we need a scale factor. So if I'm thinking of my scale factor, I need the scaled over the original. Okay, can I use, the maximum is 20 inches. So if I'm going to make it fit, I need my scale factor, but I also need to have everything in the same units. So if I use 20 inches, and that's your width, and the width is, on the Statue of Liberty is 10 feet. Remember, it's the scaled over the original. We need to change everything into the same units. We cannot compare the units of inches to the units of feet. So we'll keep the 20 inches, but 10 feet is also 120 inches. Okay, simplify. You can eliminate the tens, and that leaves 2 over 12, which is the fraction 1 over 6. So the scale factor we would use would be 1 over 6. Okay, that would be for the width. Okay, what about for the length? What about for the length? Okay, we could use 1 over 6 also. You cannot use different scale factors and have your picture look correct. So, using the parallel method to make a scale drawing with your R or your scale factor, 1/2 inch. Step 1, you're going to draw those rays. Okay, because I do not have, it's smaller, I don't have to go past C with my ray because it's going to be between A and C. Okay, if we wanted to make it 1/2, We need to have an original length. I always like to use centimeters. So this is 5 centimeters. Half of 5 is 2.5. Okay, so as we're looking at this, we're also going to do the same for the rest. This is the same as what we did on the ratio, because I do not want to use a square or a set square and the ruler, because it is very tedious and not something that most people want to do. So let's look between A and E. Between A and E is 9.2. Okay, this was AB. This will be 9.2 times 1/2, or 1/2 of 9.2. And this is AE. So that would be 4.5 plus 1, which would be 4.6. Okay, from A to C is 3.4. That would be 1.5 plus 2, which would be 1.7. So 3.4 times 1/2 is 1.7. And this is AC. And finally, for AD, it is 7.8. So 7 would be 3.5. Add 4 more, 3.9, which is right here. Okay, so I am going to create my scaled figure by connecting my dots. This will be B prime, E prime, D prime, and C prime. So to me, it's not too terribly difficult, because you can always put these in a calculator. Use your centimeters because it's going to be more accurate. It's going to be easier to multiply than using inches. So I know I'm successful when I can make scale drawings using the parallel method. And these are scale drawings. Drawing, scale drawings. You have 2 methods, and as always, I always tell you which method makes the most sense to you. If you were actually doing this, that is the method you would use. Ratio or parallel.